Hi everyone. In this video I am going to explain about the behavior of high pass RC circuit when a pulse input is applied. In the previous video you have seen the behavior of high pass RC circuit when a sinusoidal signal is applied. Later we have seen a step input is also applied, and the behavior of the high pass RC circuit is like decreasing the amplitude of the output signal, exponentially decremented signal. Now in this video the pulse input is applied for the same high pass RC circuit. This is the input voltage where we are applying the pulse input with a with the voltage as Vi of t, and the capacitor is connected like this between input and output terminals, whereas the output is taken across the resistor. Okay, C followed by R, that is the construction of high pass RC circuit, and I of t is the current flowing through the network. This is the input signal we are giving, which is in the shape of a pulse. So pulse is nothing but exactly at t is equal to 0. Below t is equal to 0, nothing but t less than 0, there is no voltage. So we can write t less than 0, input voltage is equal to 0. And from 0 less than t less than Tp, we can say that Vi of t is equal to the voltage V. And again for t greater than Tp, output input voltage is 0. This is the actual input construction we have taken for the pulse input signal. Now if such type of signal is applied to this high pass RC circuit, how the circuit behaves? Okay, now at t is equal to 0, there is a sudden change in the input from 0 to V, and we know the capacitor does not allow any sudden changes. So obviously what happens, the same change will be appeared at the output. So that's why the same V volts increment in the input signal and as well as output signal. Now from here onwards, as the input voltage is a constant voltage, the capacitor tries to charge up to that voltage. As the capacitor charges, what about the output voltage? Output voltage decreases, because when the voltage across capacitor developed, the output voltage decreases. This is the balancing of the circuit voltage across the components. Now as the output voltage decreases, and again in the meanwhile we are having a sudden change in the input voltage at t is equal to Tp, at this particular instant there is a sudden decrement of the input voltage like V volts. So the same change will also be appeared in the output, which is again V volts from here to here, and after that output goes to slowly the steady state value, which is nothing but 0. Okay, so this occurs at t is equal to Tp. Now here there are three different conditions we can come across. One is slowly charging, another one is moderately charging, and another one is the very fastly charging. Here charging is nothing but capacitor charges but output decreases. Okay, capacitor charges but output decreases. That is the meaning of this one. Now in the first case, it is tau greater than the input signal time period, or we can say pulse width. So tau is nothing but RC. RC is greater than the time period Tp. RC is greater than time period Tp means the capacitor takes very long time to charge and as well as very long time to discharge. As the value of the capacitor or as the value of time constant is more, that particular circuit consumes very lot of time to charge or to discharge to the steady state value. Okay, that's why as the capacitor takes very long time to charge and the output also takes very long time to discharge. Okay, capacitor charges means output reduces. And here go to the last case where the time constant RC is less than the time period Tp. Tau is less than Tp. As the capacitance value and the product value is very less, we can say capacitor charges quickly and discharges quickly. That's why there is almost this, depending upon this value. Suppose if this product RC is very small compared to the signal period Tp, then the shape of the signal is almost pertaining to the input signal. Now see here, it's a moderately changing where it is RC is comparable with the time period Tp. In this particular instant, the Input signal is somewhat moderately charged, neither RC greater than neither as our previous case nor the next case. Now let us see what could be the output voltage equation for this type of pulse input applied to the high pass RC circuit. Okay, now what is the shape here? What is the shape here? If you see here, it is exponentially decreasing. Exponentially decreasing. We know for exponentially increasing what is the expression, and for exponentially decreasing what is the expression we know. I will write both of them here. For exponentially increasing signal, V naught is equal to V into 1 minus e power minus t by RC. This is the expression for the signal which is exponentially increasing, like this, exponentially increasing. And for exponentially decreasing signal, V naught is equal to V into e power minus t by RC. This is for exponentially decreasing signal. So this is now in the previous case for the low pass RC circuit, as the capacitor does not allow sudden changes and the output is taken across the capacitor, so it charges always from 0. The output starts from 0. That's why this is applicable for low pass circuit. But here the capacitor is not connected across the output. We are connecting resistor across the output. So output decreases as the capacitor charges, output decreases. So it is high pass RC circuit. This is for high pass RC circuit. Hope you understand. Okay, so we need to consider this expression now. Therefore, output voltage V naught of t is equal to V into e power minus t by RC. V into e power minus t by RC. Yet t is equal to Tp. V naught of t is equal to something like a value Vp. Take this instant we are taking it as Vp. At t is equal to Tp, the output is equal to Vp. So Vp is equal to V into e power minus t by Tp by RC. T is equal to Tp. Okay, so now this sudden changes same appeared across the output, and the same voltage will be decremented by how many volts? V volts. Okay, as I explained here, that T equal to Tp, what happens? The same change will be appeared here, and there is a decrement in the output V. Now the same, hence as there is a sudden change or decrement of V volts in input, the output also suddenly dropped V volts down. Okay, so that's why yet again T is equal to Tp. V naught of t is equal to, what is the previous voltage? V into e power minus Tp by Rc. Now it is going down to minus V. Okay, so since Vp is less than V, Vp minus V is negative. Vp minus V is negative. So there is an undershoot. What happens here? See, it is going down, and here again it is coming back. This particular area, This particular part is known as undershoot. Undershoot. Actually, at this particular instant, the output should be 0. But instead of 0, still it is having some residual voltage. This particular residual voltage is known as undershoot. So there is an undershoot at t is equal to Tp, and hence for t greater than Tp, the output is negative. Hope you understand why it is negative. So for t greater than Tp, the output rises exponentially towards 0 with a time constant Rc according to that expression. What is that expression now? Therefore, the output expression for t greater than Tp is V naught of t is equal to V into e power minus Tp by Rc minus V. This is the voltage peak for the previous signal. Now at this particular point, what happens now? Capacitor is again having some overshoot that goes from negative to 0. E power minus of the t period is now t minus Tp by Rc, because we are writing at this particular instant. At this particular instant, we need to eliminate the previous time period, nothing but Tp. That's why it is like this. Okay, so this is the output voltage expression for high pass RC circuit when a pulse input is applied. See what happened now. First we have calculated what is the amplitude for this one. That means what is the expression for this type of exponential decrement. Later we have written at this particular point. Okay, I will draw a separate waveform so that you can understand very explicitly. See, this is the input waveform Vi of t and V naught of t, both I am writing here only. So it is V, it is at t is equal to Tp. Now see, I am drawing the output waveform in the red color. So as there is a sudden change in the input voltage at t is equal to 0, so output also goes from here to here. Okay, now as the input voltage is a constant voltage, capacitor slowly charges, so output slowly discharges. Meanwhile, there is again a sudden V volts decrement in the output, in the input, so the same should be appeared in the output, V volts down. Remember, this height is equal to the input, how much height that is decreased here to here. The same will be going down, but it should be stabilized to 0. That's why again it is going back towards the 0. It is time axis. Okay, this particular peak is known as undershoot. So what we are calculating, first we are writing the expression for this one, V into e power minus t by Rc. Later we are writing the expression at this particular point. What is this? Vp into e power minus Tp by Rc. Later we are writing at this particular point. What is this? Vp into e power minus Tp by Rc minus V. Later what we are writing? We are writing the expression for this waveform. It is Vp into e power minus Tp by Rc minus V into e power minus t minus Tp by Rc. Hope you understand now what are the different instances we have written the output voltage equation. Okay, this is about the pulse waveform input applied to the high pass RC circuit. Thank you.